Hey everyone, welcome back to your learning journey. Now, in this video, let's look into the expert's guide to an amazing data science career, which is an approach to MLOps. Now, as we progress in this session, we will look into the machine learning and deep learning advances that we see right now and why data science is in great demand as of now. And then we'll take a look into the hidden technical depth, the difference between DevOps and the MLOps approach, and the various MLOps approach that we have got, and how you can get started in this MLOps. So we'll see everything in detail as we progress in today's session. The overall idea for this is to give you the overall perspective as what is happening right now in the industry. All right, so let's get started, and let's start by answering a very simple and yet important question. Why data science is in great demand? Well, data science and machine learning are actually becoming one of the core capabilities for solving the complex real world problems. By the usage of these data science and machine learning, it is helping the industries to transform the way that they are doing the business. The best part is it is able to apply across all the domains. Now, the key ingredients for having these kind of development right now is one, the availability of large data sets and inexpensive on-demand compute resources. Now, previously, if I wanted to run any execution, I had to have a high-end laptop. Now, I don't have to worry about it. I can just rent the servers on AWS or GCP, which is quite inexpensive compared to what we had earlier. And we can train the model. And once we have trained, we can switch off the instance. It's like getting the electricity bill on the basis of our usage. And the best part is the specialized accelerators for machine learning on various cloud platforms, whether it is Azure, GCP, or AWS. We've got various specialized accelerators that are available for the practitioners as well as the industries to apply the machine learning for their given data set and get the most of the data that they actually have. And also, the recent advances in the various machine learning field have resulted in delivering the more value to the industry, which in turn actually helped the jobs as well. And it actually, like, because of all this reason, so many business are actually investing in data science teams as well as the ML capabilities, and that is the reason that we see a lot of demand for the role of data scientists and the machine learning practitioners. Now, you know why data science is in great demand right now and what is the key reason behind it. Now, when we talk about this overall data science and applying the data science at an industry level, so here in your learning journey of data science, I'm sure you will be learning or training the model in this specific way. You'll be having a data set. So in this data set, you are going to split the data into two parts. One is a training part and the another one is a test part. So what you will do, you will train your machine learning model in an intention that it is able to generalize the overall pattern that is present in the data set. So once you train the model, you're going to test that model with the help of the test data which you have actually kept aside. And using this test data, you are going to measure how the machine learning model is actually able to generalize from the given data set. Now, that's what we generally do in the scenario of machine learning. Now, when you think about it, the challenge is building these kind of system to continuously operate in the production, integrated to the current environment and integrated to the current infrastructure that they have. Now, this picture that you see right here, so you can clearly observe that only a small fraction, yes, only a small fraction of a real world ML system is composed of the machine learning code. Now, if you look into the surrounding items, which is actually required to run this machine learning code, it could be configuration, data verification, feature engineering, automation, testing, resource management, infrastructure, monitoring. So you can look into the various components. So what exactly the rest of the system is actually composed of. Now, to develop and operate the complex systems that you see right here on the screen, so you can only apply the DevOps principle to the ML system, and that's what MLOps is all about. Here, when we talk about this DevOps, so what exactly is this DevOps? DevOps is a popular practice in developing and operating the large scale software system. Now, by using this DevOps, so this will provide the benefit to us like shortening the development cycle, increasing the deployment velocity, which means you can actually deploy the application version, you can push the application version as and when it is ready, and it will have a dependable release. So these are some of the great benefits that we have got with DevOps. Now, in order to achieve these benefits, so here in the scenario of DevOps, so you basically hear two terms normally. One is continuous integration and the other one is called as continuous delivery. Now, when I say continuous integration is actually a practice of merging all the developers' working copies to a shared main line. It could be several times a day. So here, when we talk about the continuous integration pipeline, one of the commonly used tool is the Git. And when I say continuous delivery, so continuous delivery is nothing but it's an approach where teams produce software in short cycles, and this will ensure that software can be readily released, and we'll say reliably released at any time. Okay, and this can be automated, and that is what we call it as a continuous delivery cycle. And this continuous integration and the continuous delivery forms one of the key part in this DevOps. Now, if you think that, okay, so we can apply this DevOps approach onto the machine learning system because that's also a software system, isn't it? But there are some key challenges that we have got in machine learning. If you think closely, one of the major difference that we observe, one of the key thing that we observe in the machine learning project is team composition. In a machine learning project, so the team that you will have the team of data scientists, you will have the team of the infrastructure, you will have the team of software engineer. So there are various team members from various domains will be working in a team. And another important thing is development aspect. Now, when you talk about the development of the machine learning code, it's all experimental in nature. First, you are going to explore the data and you will apply various machine learning model depending on the model's ability to generalize it. So you are going to select the model. I would say everything is in experimentation. Now, once you select a model, you are going to perform the hyperparameter tuning and you're going to improve the model performance. So the development process is very unique compared to the software development process. And also, when we talk about the testing, so testing is also little different. Here in the scenario of software testing, you're going to do the unit testing, functional unit testing, integration testing, and so on. Now here, along with the testing of the overall enterprise software that you actually have, you also require the data validation. You also have to ensure that the data that you're doing for testing, so that represents the overall population of the data that you have got. And not only the code is involved in this scenario, the data is also involved in the scenario of testing phase of machine learning project. And then deployment. So when you think about the machine learning system, the deployment is not as straightforward that as you would see, as you might have experienced. So it's not as simple as getting the offline trained model as prediction service. So you cannot just take the trained model and place it somewhere. So in order to deploy this machine learning model, you have to deploy a multi-step pipeline so that it can automatically retrain as well as deploy the model. Now this pipeline itself is going to add the complexity. And here, in order to ensure that it works perfectly, you have to automate the steps which are actually done before this deployment. So let me just give you an example for the deployment example. Let's say you have got the data set. On this data set, before training, you have performed the data standardization and you have also removed some features and you have also added some features for this given data set. That means you have performed the feature engineering. Now on this data that you have actually prepared, if you want to ensure that this trained model that you have got after you have done the standardization and the feature engineering, this trained model instance, you have to then place it in the production server. Now to ensure that this model would work effectively, Before you send any new data for this model, the new data that you have, it has to pass through your data pipeline. It has to perform the standardization as well as the feature engineering, and then it has to generate the prediction. So this pipeline activity is the one which is going to add the complexity when it comes to deployment. And then production. So machine learning models can have lot of things. I mean, lot of things can go wrong when we talk about the production deployment of machine learning. So it may not be always related to the coding. It may be because of data profiles which are getting involved, or the model performance that we have, it may decay due to the oncoming data. So at that time, even when it is deployed to production, you have to track the summary statistics of the data, monitor the online performance of the model, send the notification or roll back when the values deviate from the expectation. You have to monitor after this production deployment. So as you can clearly see, the ML system is very different to what you might generally come across in a software environment. Hence, you have to ensure that if you're thinking of automating every process, you have to keep these things in mind. Now that you have seen what a machine learning system is and how is it different from the software engineering and the general software deployment, if you're someone who is very new to data science and not sure how to get started in your learning journey, so the simplest way is to start by learning the statistics, because statistics is the one that will help you to learn the data in an effective manner. So check out our course on our YouTube channel, which is a free course which has been created with proven learning methodology so that you as a learner can learn and can understand the concepts of statistics in a simple and an intuitive manner. All right, do check the link in description for this course link. Now moving ahead in your learning journey. Now when we talk about this data science and in machine learning in general, so we follow a methodology when it comes to working. So first thing that we do is we perform the data extraction, and the second step is data analysis. The third step is data preparation. So the fourth step is model training. So if I say data extraction, it can be selecting the data, integrating the data from various sources, and then prepare it so that you can perform the required analysis on the data set. And in the step of data analysis, you are going to understand the data schema, characteristics, types of data that you're dealing with, change the data from one data type to another data type. And in the third step of data preparation, here you will perform the cleaning of the data set, split the data into various parts as per your requirement. And in the model training phase, you are going to implement the various machine learning algorithm and train the algorithms such that which will ensure that it will generalize the data in a best possible way. And once that is done, you're going to evaluate the model, followed by model validation step, where you're going to check whether the model is working as per the company's expectation. Post that, you're going to serve the model. So you can deploy it as a microservices with REST API, or you can create it as an embedded model to an edge or a mobile device, or you can also create a model which will serve as a batch prediction system. So there are various options that you have got over here when it comes to model serving. And at the last step, you will have model monitoring, where you're going to monitor the performance of the model to potentially give us a signal when the model is decaying on the overall working with the new data that is it is actually getting. Now that you have looked into a various steps that is involved in data science. Now when we talk about MLOps, it's about using the DevOps strategy of continuous integration and continuous deployment into the machine learning system. Now, in order to do this, so normally when we start building any POC or when we start any machine learning project, so it will be a manual process. So here in the manual process, you will have a data. So you'll have the team of data science and machine learning researchers, and they are going to build the state-of-the-art model. And here, when it comes to building and deploying this machine learning models, it's completely manual, which you see here on the slide. Now, this is a basic level of maturity or level 0, which we call it. And I've got this diagram from the Google. So from the official Google page, I've got this diagram. So the key characteristic over here in this manual process is everything is script driven as well as the interactive process. So every step that is being performed, whether it is data extraction, data preparation, model training, evaluation and validation, and then once you have got the trained model, place it in a model registry. Model registry is nothing but it's a central repository which has a versioning ability present over there so that you can switch back to the required version at a later point as well. And then from the model registry, the operations team is going to get that model which is a required model, and then they are going to ensure that this model can be servable. Now in this manual process, obviously there's no continuous integration is involved and there is no continuous deployment is involved. And then another thing is it's complete disconnection. You can clearly observe the machine learning developers and the operations team both are disconnected. And as a result of this, there is no active performance monitoring that we will have in the manual process, which is a general methodology it's like a POC. Whenever we are creating the POC, we'll generally follow this manual process. Now, this level 0, as I mentioned, it is common in many business which are beginning to apply machine learning for the use case. Now, in some scenarios, this data scientist driven process might be sufficient when the models are rarely changed or when they are rarely trained. But in reality, that's not how it works, isn't it? So we have to actively monitor the quality of model in production. Just imagine that you have trained your machine learning model, which is going to flag the transaction whether it is fraudulent or not. Now, after some time, the performance of the model deteriorates, and once it deteriorates, what will happen is like once the model's performance become worsen, so it might predict every correct transaction as a fraudulent transaction, which is going to hamper your customer experience. So in those scenarios, you have to actively monitor the model performance, ensure that you are getting the required efficiency from the model. So in order to do that, you have to perform the frequent retrain. So what you will do is you'll think about some kind of an automation, which we call it as MLOps level 1. Now in this MLOps level 1, we call it as MLOps, that is machine learning pipeline automation. So here the overall goal over here is to perform the continuous training of the model by automating this machine learning pipeline. Okay, you're going to automate this machine learning pipeline, and this will help you to achieve the continuous delivery of the model prediction service. Now, once you have trained, you are going to save this trained model into the source repository. So as a result of this, so you will have the continuous training approach. Now, to automate the process of using the new data to retrain the model in the production, so obviously you have to introduce the automated data and model validation steps to your pipeline. And also ensure that you have the proper pipeline triggers as well as the metadata management so that the continuous training will be successful. So as a result of this, you will be able to perform the experiments in a much more rapid pace, and you will have the continuous training of the model in the production. And along with that, you will have the modularized code for components and the pipeline. Okay, now going along, so you can actually move to the next level in MLOps. So if I want to talk about the level 2 in MLOps, so that's the phase where we will have CICD pipeline automation. That means we bring in continuous integration and the continuous delivery as well into our machine learning. So here the key characteristics of this MLOps setup will be something like this. We will have the source code. Now this source code, whatever the changes that we do along with the artifacts that we will have, so we will have the continuous integration service which will be with us. And with this continuous integration, so we will have created as a package. Now with that package created, we are going to ensure that we will have a continuous delivery pipeline, and then with the automated pipeline we will have the continuous training, and as a result of this, at the end we'll also have a continuous delivery of the model that has been trained to our production service. So these are some of the key stages that we have got in the CI/CD automated machine learning pipeline. So under the development and experiment, we actually try out the various machine learning algorithm and the modeling where the new experiment steps are actually orchestrated. And under this pipeline continuous integration, so we are going to build the source code and run the various tests. And then we are going to generate the output, and these output will be generally packages, executables, and the artifacts which we have to deploy to the later stage. And under this pipeline continuous delivery, we are going to deploy the artifacts produced by the continuous integration stage to the target environment. Now let me give you an example for artifacts. So here for the artifacts, it can be the model that has been trained, or if there is any variable that you have created which will help you to perform the pre-processing, like the one hot encoding. So that variable that you have created which has learned from the training data set, so that is a data pre-processing object. Okay, I'll say pre-processing object. That will also be an artifact over here. And if you have used any external file, that external file will also be an artifact. So all these things will be considered, and this would ensure that this will be placed in a required target environment, which is required for us for the production environment as well. And then we will have something kind of an automated triggering or the automated pipeline. Now here, this pipeline will be automatically executed in production on the basis of a schedule or in response of a trigger. Now this can be as like every 6 months do the trigger, or when the model efficiency goes less than 90%, go ahead and trigger the retraining. So that is what we call it as an automated pipeline triggering. And then we will have the continuous training, which is the outcome of this automated pipeline or from the trigger that we have got. And then we will have the trained model, and using this trained model, we are going to perform the continuous delivery of the model. So here we serve the trained model as a prediction service for the predictions, and the output of this stage is a deployed model prediction service. And finally, you are going to continue to monitor your machine learning models. So this is what your pipeline would consist of in the MLOps approach. So to summarize over here, I can say that when you are implementing the machine learning in a production environment, it just doesn't mean that you're going to train the model and you're going to deploy it as an API for the prediction. So it actually means deploying a machine learning pipeline which can automate the retraining as well as deployment of new models. Now, by setting up this CI/CD system, it will enable you to automatically test and deploy new pipeline implementation. And as a result of this, this will help you to cope with the rapid changes that is happening with the data as well as the business environment. Now, remember, now all these steps that I have actually talked about, you don't have to move directly from one level to another level. It all depends on the business in which that you're operating and the maturity that you have got in the team as well as in your project. So you can gradually implement these practices that I have described right now, which will help you to have an automation in your machine learning system for development as well as production. So with this, we come to the end of this video, team. So thank you so much for watching and staying with me till the end. If you have got any questions, please let me know in the comment section. And if you want me to create a hands-on demonstration of implementing this CI/CD automation with a machine learning model, do let me know in the comment section, and I'll do my best to add it in our future learning journey. So thanks again for watching, and I'll see you next time.